refers to value of y, domain refers to the value of x. So let's look at example 2 here. In this example, we are asked to determine the domain and range of the following functions. Okay, the first line, y equals to 3x. So the first step is to draw the line. Alright, so we have y equals to 3x. Then take a point from the line and then draw dotted line towards the x-axis. Alright, so we draw dotted lines towards the x-axis. So we can actually draw a lot of points here towards the x-axis, and since this graph y equals to 3x has no ending, we can actually prolong this line until infinity. Therefore, the value of x here will move towards infinity. So the same goes for the negative side of the graph. If we take a point from the line y equals to 3x and then draw dotted line towards the x-axis, since this line will continue below, hence we can say the value on the negative axis will continue until infinity. So we have infinity value of x here, and we also have infinity value of x towards the positive side. So in other words, the value of x will be all the values on the x-axis without any ending. So therefore we can conclude that this for this graph, the domain is equals to all values of x. There's no ending, where as long as the x is a real number. So x can be any value as long as it is a real number. Okay? Now what about the range? So range refers to the green lines here. In order to find the range, we've got to take a point from the straight line just now and then draw dotted line towards the y-axis. So the next point here, we draw another point on the y-axis, and since this line will continue without any ending, therefore the value of y positive will continue until infinity. So the same goes for the negative part. If we take a point and then draw a line towards the y-axis, we will realize that the value of y will continue until infinity. So we have positive infinity, we have negative infinity. In other words, the value of y can be any value on the y-axis, right, without any ending. Therefore, we can say the range is equal to all values of y, where y must be a real number. So as long as y is a real number, then we can say the range represents all the y values. Okay? Right, let's look at example B here. For y equals to x squared, so we sketch the curve y equals to x squared. Again, to find the domain, you need to take a point, a point on the curve, and then from there draw dotted lines towards the x-axis. So if we continue plotting the curve, drawing those dotted lines towards the x-axis, and since this curve will continue until no ending, then we can say the value of x here will move towards infinity, no ending. The same goes for the negative side, will also move towards infinity. Therefore, we can say domain of this curve will be any value of x on the x-axis. Since there is no ending, then we can say that x must be a member of real numbers. Okay? Next, if we look at the range, range refers to the y value on the y-axis. So again, you take a point from the curve, draw dotted line towards the y-axis. Alright? So we actually can draw a lot of lines here until infinity, since the curve has got no ending. So the value of y will be infinity towards the positive. But how about the negative side? Here there is no value of y below the curve, because the minimum is up to this point. Y equals to 0. So therefore we can say the range of this curve will be any value of y which is positive. but minimum y equals to 0. So if we write in a proper way, we can say range of this curve are all the values of y, where y must be a member of R, but limited by this condition, where the value of y must be 0 or more than 0. So we say y is greater or equal to 0. Okay? Next, in example C, we have y equals to 1 over x. If we sketch the curve, we will get two curves for this kind of equation. So again the same, we have to take any point on the curve and draw dotted lines towards the x-axis. So we can see that all this x will continue until infinity. Okay? Until infinity. The same goes for negative. But this type of equation, the curve doesn't touch the y-axis, right? It doesn't touch the y-axis, it doesn't touch the x-axis. So therefore we can say, yeah, the domain will be any value of x until infinity, but it must not be equal to 0 because it does not touch the 0. Okay? We can actually check by substituting the value of x equals to 0. So we realize that if we substitute x is 0, we will get 1 over 0. And 1 over 0